Today we're going to be looking at how to communicate about variables. So we're going to start by looking at some not so good examples of communication, starting with this lovely example, which is several years old, but it was from when I lived in Minnesota. We had DirecTV, and this was presented to me in an ad for why I should be using DirecTV. 95 of my favorite channels. How do they know what my favorite channels are, especially because I don't watch TV? I don't know. 81 channels from Dish Network, which if we do some quick math, that is 14 fewer channels. However, this rectangle looks to be at least twice as big as this rectangle. Is 95 twice as big as 81? No, but it does look like it here. Now I know this isn't really a graph, like there's no label on the horizontal axis or vertical axis, but they are presenting it like a bar graph, so it is a little bit misleading. Here's another example. Once again, we have a bar graph comparing two different years, and we're looking at the knuckleball velocity of this particular player. 77.3 miles per hour in 2012, and then all the way down to 75.3. Now, if you didn't have these labels here, you would think that he is throwing significantly slower. This looks like half. I'll draw one over here. Well, not my best work, but yeah, like less than half. However, 75.3 is not that much smaller than 77.3. So they've probably had a graph that looked like this and thought to themselves, well, that's not very exciting. Why don't we just take this part of the graph? Ooh, so much more exciting. So by cutting off just the top part of the graph, we lose most of the range, and that makes something that is extremely misleading. And then here we have some examples that students have sent me over the years. Over here we have another example of where like the top of the graph is just cut off and we don't have the full range. And that's actually happening on the presidential height graph as well. So the red bars are showing the president's height and the white bars are showing the average US citizen born the same decade. There's some funny examples here like FDR, Roosevelt. He looks like he's 2.5 times as large as the average person, when in reality, they've just cut off the top of this graph. Harrison over here, half the size of everybody. And then this example over here, I don't even. So in the interest of communicating well about our variables, we have two questions that we're going to be asking in this video and hopefully answering. First is, how do we talk about variables? Now there are two different types of variables we are going to be studying. One is called categorical and one is quantitative. Categorical is when you have a certain number of categories that people can answer. Whereas quantitative is where you could have a scale to represent the different answers that people might present. For example, if I ask you, do you watch American Idol? Your answer is either yes or no. That's a categorical variable because there are two categories. A quantitative example would be, how many American Idol winners can you name? You can probably name 0 to 2. You would think 3, but it's not 3, it's actually just 2. That's quantitative because there's lots of different numbers that people could answer, and at the end I can say, once I've gathered the data, I can say the average number of winners people can name is 1.5? I feel like it'd be 1.5. Then the next question is, how do we represent those variables? For each variable, you can represent it numerically or graphically. In this video, we're going to focus on categorical variables, and we're also going to do both numeric and graphic representations. So, to get started, you should have a link to this Google Doc in the description of the video. I mentioned this in the last video, but once again, you're going to get much more out of these videos if you do the activities along with me. So what I want you to do in a moment is pause, fill out the Google form. It'll take approximately 9 to 10 seconds. Then click here to see the results and fill out this table. I'm going to pause the video as well and fill in my information. It's probably going to be different than yours, but that's okay. So just fill in what you have. Okay, at the time of filming this video, here's where we were at. I asked some former students to fill out the survey. Your numbers are likely different, and that's fine. You can still get the same information from this video, the same content. I wrote that in blue. I'm going to go through in orange and just note some kind of vocabulary that we might want to keep track of. This first column is showing us frequencies. It's the number of people who prefer each elective, whereas the percent row is showing us relative frequencies. A relative frequency is when you compare the counts to the whole picture, and it gives us a little more context and a little more information. Instead of just saying 16 people like physical education, I can say 22.9%. If I just say 16, there's no context, because do I know if the survey was sent to 100 people, a million people, 16 people? Like that, those are all big differences. Now there is an example of this. It was back when Jimmy Fallon was doing the late night show, not the Tonight Show. And it was right after Justin Bieber got 40 million followers, which at the time I believe was like the most Twitter followers anyone had. It's like more than Barack Obama. And he tweeted this beautiful, well-crafted tweet, and he got over 100,000 retweets. So then Jimmy had one of his writers, Arthur, tweet the exact same thing, and he got 452 retweets the first time, and then the next time it was 4,085. Now there are other videos that I don't think are on YouTube anymore of the first day of the week he did this, but we're looking at like by the 4th or 5th day they'd been doing this. Now you can watch the video. It's not officially on Jimmy Fallon's channel, so I don't know how long it'll be available on YouTube, but I can link it below and then you can try to watch it if you want. This is like a punchline. You know, he says he got 452 retweets and people laugh because they were just presented this number. However, if we look at relative frequency instead of frequency, we can see that less than 0.5% of Justin Bieber's followers retweeted. And then we look at Arthur. The first time he tweeted this, he got 0.9% of followers to retweet, and then he got a stunning 8.4% to retweet. The frequencies here are drastically different, but the relative frequencies tell a much different story. And yes, that's what I thought when I watched that clip. Now, a relative frequency goes by many names. That whole row of the table, we could call those percents. If we change them into decimals and said 0.243, 0.171, we could call them proportions. We can call them relative frequencies. We could also call them rates. Sometimes we call them probabilities, like the probability that someone likes music or technology. All of those mean the same thing. And these are the two ways that we can numerically represent categorical variables, with a frequency table or with a relative frequency table. Now just a bit more vocab. The individuals in our study are the people or the things that we are studying. So in this case, it was originally some students. Now it's students and anyone watching this video on YouTube. So the individuals in this study are anyone who's done the survey. The variable that we're studying, that's the thing that we're asking people to, the question we're asking people to answer, or the number that we're gathering, the data we're gathering. In this case, it's favorite elective. And we've already kind of discussed that this is a categorical variable because there are a certain number of categories that this variable can fall into. Now, when you're representing a categorical variable graphically, you have two options. You can make a pie chart or you can make a bar graph. I would highly recommend, since these are basically your notes, that you just do a sketch and only a sketch, because a pie chart is kind of a pain to do by hand accurately. Google Forms gave us this, which is really nice. Now, once again, yours might look different. But just a quick sketch in your notes is all you need. You don't have to like get out your protractor or anything. A pie chart is fantastic if you want to compare parts to a whole, because it really clearly illustrates like what part or what fraction of the whole each category takes up. Like it's illustrated for me. I can see what 24% looks like. I can see that it takes up almost a quarter. I can just see it. Now, obviously this needs a key. I didn't copy paste that from Google Forms, but it should be telling us which section is which. That would be helpful. A bar graph is when you have a bar representing each category. So I have them labeled down here. And then along here I've labeled this frequency, not relative frequency, although you could do that if you wanted to. And I'm just representing the straight counts in each bar. The benefit of a bar graph is it's much, much easier to make by hand and have it be accurate because you can easily make a scale, but usually we'll have technology. So it's kind of up to you which one you use. You only want to use a pie chart if you're comparing parts to a whole. It would not work if you had things that didn't add up to 100%. Okay, now we're going to bring in the second variable, which is whether you are left or right-handed. Someone's having a great Sunday. I'm like honestly very happy for them. Okay, some people believe that left-handed people are more artistic or creative, but there has been research that's shown that it does not matter what hand you use to write. But we're not really going to get into that. I just needed a second variable to compare. So what we're going to do is we're going to compare right and left-handed people to their favorite electives. So what you should do now, in a moment you're going to pause the video, you're going to click here to see the elective data that I have sorted by right and left-handed people. Copy that table in below. If you would like, you can try doing these 3 questions and then hit play. Okay, so once again, your numbers are probably going to be different than mine, but that's totally fine. Percent of people who chose art. Okay, now this question mentions nothing about right-handed versus left-handed. We're just thinking about overall how many people chose art. Well, that was 17 people overall, and there were 70 people in the study at the time of me doing this. I've written that number like 6 times by this point of filming. I don't know why I just typed that in my calculator, but okay. There's the percent of people who chose art. Okay, percent of people who chose technology and are right-handed. So let's get the highlighter out here. Technology is this row, right-handed is this column. The number of people who chose technology and are right-handed is 70. Total, 70. 10 is 10. I highlighted 10 while I said a different number. Yikes. Okay, the number of people who chose tech and are right-handed, there are 10 of those people. Total, there are 70 people in the study. So this is 14.3%. So it's asking us and. This next question though says percent of right-handed people who chose technology. Now this is a different question. The percent of right-handed people. So now we're only focusing on this column. Only the right-handed people. Of the right-handed people who chose tech. Well, there were 10 people who chose technology of the right-handed people. But there were only 58 right-handed people in the survey, not 70. So we're looking this time at 10 over 58. The key here is the word of. We're not looking at right-handed and technology, we're looking at of the right-handed people, what percent chose tech. All right, I'm going to switch to another color now because we're looking at some vocab. This first percent is called a marginal relative frequency, because you'll notice we looked all the way to the margin to get that frequency. Another way of thinking about it is we're only focusing on one variable instead of 2. So we're ignoring right and left-handed people completely, and we're just looking at elective. The second example is a joint relative frequency, because here we're joining 2 different variables. We're looking at technology for the elective variable and right-handed for the handed variable. So this is a joint relative frequency because we're looking at something and something else. This last one is called a conditional relative frequency because we created a condition. Of the right-handed people, what percent chose tech? Okay, the next thing I want you to do is pause the video and try to answer questions 1 and 2 on your own. This first one we've already kind of answered. There are 2 variables in this table and they are both categorical. There are only a certain number of categories you can respond with. In the survey, they were multiple choice. You weren't just typing in a number. And then which variable would best explain or predict the other? Now you could argue this, well, you might have a hard time arguing it the opposite way, but what I said was probably whether you're left or right-handed could explain which elective is your favorite. Now, as we mentioned, that might not actually be true, but that's kind of the myth. If you're left-handed, you're more artistic. So left and right-handedness is explaining your favorite elective. In orange, once again, I've noted some vocab we should be aware of. The left and right-handed variable could be called the explanatory variable because it's explaining the other. The other variable, favorite elective, can be called the response variable because that's the response we're getting from the explanatory. The most obvious example I can think of off the top of my head is an explanatory variable like how much do you smoke? Response variable, do you have lung cancer or not? Smoking explains whether or not you have lung cancer. So now we're going to look at how we can graphically represent two variables at once. The graphs that we made before, the pie chart and the bar graph, those represented a single variable, but now we have two. So the first graph that we can make is called a side-by-side bar graph, which is basically just two bar graphs that are side by side. I know, crazy. So what I've done here is I've made one bar graph for right-handed people and one bar graph for left-handed people. Because I said that right and left-handedness is maybe our explanatory variable, that's how I split up the two graphs. You could also say I'm going to make one for art, one for music, one for PE, but I chose to just split up based on those right and left-handed variables because that's the variable that we think is explaining the other. So you can see along the vertical axis I've labeled frequency, and then I gave a different color to each elective. It's kind of hard to see the yellow, I kind of regret that. So that's called a side-by-side bar graph. Very easy to make by hand. The next type of graph is called a segmented bar graph. Now for this, instead of frequencies, I'm going to change to relative frequency, and I'm going to make this one along with you guys. So I'm going to label this relative frequency. I've labeled this from 0 to 1. So I'm not really thinking about percents, I'm thinking about those percents as decimals. And we're going to start with art. Art had 14 out of 48 people at the time that I did this. So for art, 14 out of 48 right-handed. So this is art over right-handed. This is a conditional relative frequency because I've given it a condition. Of the right-handed people, what proportion or what percent like art? So of the right-handed people, 14 like art. That is 24% or 0.24. So that's about here. So there's art. For music, of the music people, of the right-handed people, 10 prefer music, and there were 48 right-handed people. So of the right-handed people, this many prefer music. That's 20%. So that would be, it's a little bit smaller than the last segment, so I'm going to go like here. Yeah. Now, before I get too far, I'm just going to color code these. PE, now that one was the same number as art, so that was also 24. So let's see. 24% plus 20%. We're currently sitting at 44. We're going to add another 24%. That's going to get us to 68. So that'd be somewhere up here. Slightly more people liked art and PE, but not by much. Okay, so I'm going to do the same thing. This was right-handed. I'm going to do the same thing with left-handed. At this point, you should pause the video, and like I said, you will get more out of this if you actually do it. So pause the video and actually do these graphs for your data, keeping in mind that it'll probably be different than mine. Well, I'm curious to know if your guys is different than mine, because mine, the two bars look almost exactly the same. Oh my gosh, all that work to try to make it precise and they end up looking about the same. It's still interesting, it's not as dramatic as I was hoping, but that's fine. Okay, last but not least, we have a mosaic plot. Now, a mosaic plot is essentially a segmented bar graph, but it addresses another question. When you look at this segmented bar graph, it's impossible to tell the ratio of right-handed to left-handed people, okay? When I look at this, I don't know if it was 50-50 right and left hand, or if it was all right-handed people except for like 5 left-handed people. The mosaic plot takes care of that.
1 minute, 37 seconds later.
So far, all I've done is I've just copy-pasted this segmented bar graph over here. Now for the mosaic plot, I want to represent the difference between right and left-handed people. So I had 48 right-handed people total out of 70, which is 68.57%. So what I'm going to do is I'm going to add a scale to this axis. Okay, now since there were 68% of people right-handed, I'm just going to take this, and once again, I know you can't do this. Oh, it's not going to let me stretch it out. Why though?
One eternity later.
Okay, here's the mosaic plot. What this has allowed us to do is add in another dimension of information. I can now see that over half of the people who did the survey were right-handed. So by making the two segmented bars also proportional, we can add in this new dimension where now we can compare the relative frequencies for classes and the relative frequencies for right and left-handed people. Okay, try to answer these last couple questions on your own. So pause the video, do those now. Okay, so let's look at these questions together. Well, the bars in the side-by-side graph have just been stacked to make the segmented bar graph. That's all we've done. We've taken these bars, stacked them up, we've turned them into relative frequencies, but really that's how they relate. And then the bars in the segmented bar graph have been made wider or narrower to create the mosaic plot. And that's once again to show the difference between right-handed and left-handed. Is there an association between right versus left-handedness and favorite elective? Now this is where your answer might be different than mine. My answer, if I look at my segmented bar graph, I see two bars that look almost exactly the same. So for me, my answer is no. The bars in the segmented bar graph do look the same, or mostly the same. Now, if my graph looked more like this, then maybe I could say, yes, there is an association. It looks like there's many more left-handed people who like creative electives like art and music. In my case, no. They're almost the same. If there were not an association between right and left-handedness and favorite elective, what would the bars look like? They would look like my boring graphs. There's no difference. The two segments are the same. The two bars are the same. If there were an association, we would expect to see something like this, where we could say, wow, left-handed people are more likely to take creative electives. Hopefully this video has helped you see that it's really important the way you represent your variables, especially with categorical. Whether you choose frequencies or relative frequencies, pie charts, bar graphs, segmented bar graphs, mosaic plots, the way you represent your variables can really change the way that people interpret them.